Welcome back to my channel. Today we're going to go over reflections, which is 8.2. So same standard, GCO 5. It says given a geometric figure and a reflection, draw the transformed figure, specify a sequence of transformations that will carry a given figure onto another. So some vocab, reflection, and line of reflection. Okay, looking at the shapes at the right, visualize flipping each shape across its yellow line. So they all have yellow lines. What word do the images of the shapes form? Copy the shapes as they are shown and sketch the results. So let's do that here. See if it will work. So if I flip this one right here over the yellow line, it's going to look like this. If I flip this one down, it's going to look like this. Nope, just kidding. It's going to come down like this, and there, and back like that. That one's going to flip over and make this, this, and that. Okay. And then this one is going to flip down and make this. So that looks like an N to me. Alright, and then let's flip the rest of them. So this little trapezoid over here is going to flip and make another trapezoid like that. This one's going to flip up and be something like that. This one flips down like so. What is happening there? This one flips over, I guess. It's like that. And then this one flips across as well. Like that. That's an E, maybe. Alright. And this one flips across, like so. This one. Okay, so these two are both connected to the same line, so they're just going to swap spots. So the trapezoid is going to be like, come on, like this. And then it's going to go down like that. And then my triangle is going to flip over like that. Alright, so, I forgot to draw that. So it makes the word net. That's what it looks like to me anyway. Awesome. Next slide. Those are all reflections. So you're just reflecting. You always reflect over a line. Okay, next. Let's go. Okay. Notice that when you reflect a figure, the shapes have opposite orientations. So, for example, if you look at these triangles here, triangle BUG, if you go in the clockwise direction, it's BUG. When you flip it, this U comes over to here, and now it would go counterclockwise to read BUG. So the orientation flips, and that's what that means. When you reflect a figure across a line, each point of the figure maps to another point that is the same distance from the line, but on the other side. So each of these points, U to that line, is the same as the distance from that line to U prime. Same with B. In order to precisely define reflections, we need to use the perpendicular bisector of a segment. We talked about that. We talked about constructing that last unit. A point is equidistant from a set of other points when it is the same distance from each of those other points. So equidistant just means it's the same distance. Okay, so here's your key concept. A reflection across line M, so if you can see line M over here, that's this line right here, called the line of reflection, so that's the line you're flipping it over, is a transformation with the following properties. So the first one is says if a point A is on the line M, then its image is going to be itself. So if it's on the line, it doesn't move. If a point B is not on the line,
are you making a video?
Alright, if a point B is not on the line M, then M is the perpendicular bisector of B to B prime. So that means if you draw that line from B to B prime like this, should be a straight line. M, the perpendicular, or the line of reflection, is going to cut that in half and make a right angle. Okay, and the way we write reflections, we use R, capital R, for reflection, and then this right here is talking about your line. So we use line M there. P is the point, P prime is the new point. So pre-image, in parentheses, new image on the other side. Alright, so it says you can use the equation of a line of reflection in the function notation. So for example, capital R, y equals x. This is just saying that you're reflecting an image over the line y equals x. Alright. Okay. So let's look at this example. So point P has coordinates 3, 4. What are the coordinates of this reflection? So you're reflecting over y equals 1. So with these, it's probably just best to graph and then reflect. So 3, 4 is going to be over 1, 2, 3, up 1, 2, 3, 4. Alright, so the point is at 3, 4, so over 3, up 4. Right there-ish, and that is point P. And you're reflecting over this line, y equals 1. So to graph that, that's telling us it's going to cross the y-axis at 1. So if we go to 1 on the y-axis, and I'm just going to use a dashed line here. That should be your line. Okay, and it's just a constant number, so it's just a horizontal line. If it was x equals 1, it would be a vertical line. So now we're going to flip the point P over that line. So to do that, you just count the distance from the point to the line. So you're going down 1, 2, 3 units. So then you go down 3 more units. 1, 2, 3. It's going to be right here. And that will be P prime. So P prime should be 3, negative 2. Alright, okay. So you can try this next problem, 3, 4, but now you're reflecting over x equals 1. So it's going to be the vertical line instead. So pause this in 3, 2, 1, pause. Alright, so this one is a vertical line because it's x equals, so it crosses the x-axis at 1. So it's going to reflect horizontally across that. So you're going to go over 1, 2, 1, 2. So that point should be negative 1, 4. Okay. You can also use the notation R subscript M to describe reflections of figures. Okay, so this is if M is just the name of the line, so essentially the same thing. So reflections preserve distance, that means all of the lengths of the sides are going to be the same. They also preserve angle measure, so all the angles stay the same. And reflections map each point of the pre-image to one and only one corresponding image. So there's only one other point that it can go to. That's basically what that's saying. Okay, so this means that all reflections are also rigid motions. So translations and reflections, both rigid motions. Alright, so this one we need to graph the points and then reflect it. So 1, 2, 3, 4, 1, 2, 3, 4. Alright, so A is at negative 3, 4, so back 3, down 4. B 0, 1, and C 4, 2. C. Oh. Okay, so we have this triangle here, and we're reflecting it over the y-axis. So that's going to be the y-axis. So right here. So to do that, our shape kind of overlaps the y-axis. So B is going to stay where it's at because it's on the y-axis. So B prime is still right here. A is going to flip over, so it's going to go over 1, 2, 3. So I'll go over 1, 2, 3 more. So this is going to be A prime here. And then C is going to go back 1, 2, 3, 4. 1, 2, 3, 4. So this will be C prime here. And then we can connect those. I should probably use a different color. That would be the reflected image. Okay. Right, this one it says each triangle in the diagram is a reflection of another triangle across one of the given lines. How can you describe triangle 2 by using a reflection rule? So triangle 2 is over here. So that's going to be this triangle 2 here. That's going to be the same as, well, not triangle 3 because that would be a translation. Not triangle 1 either because that's on the complete other side. So it would be a reflection of triangle 4. So if you're going to write the rule, you'd say we're going to reflect, so capital R, over the line, this one's going to reflect over the line K. So I'm going to put K down here, and I'm reflecting triangle 4, and that will give me triangle 1. Okay, and that's all it wants you to do. Just describe the rule. And that's it. Okay, if you wanted to describe 1, you could say it's a reflection of 3, but that one's reflecting over line M instead of K. Alright, and last one says you can use the reflection properties to prove statements about figures. So in the diagram, RTG, reflection across T of G equals G, that means it doesn't move. If you reflect H across T, it turns into J, and if you reflect D, it stays the same. Use the properties of reflections to describe how you know GHJ is an isosceles triangle. Okay, so you know that G and G are the same point. You know that H and J are reflections of each other. So that tells us that GH should be the same as GJ. And because those two are the same, that tells us it's isosceles because at least 2 of the sides are the same. Okay, we don't know if it's equilateral or not because we don't know about this third side right here. Alright, and that is all for reflections. So, and here we have a special word from our sponsors. Take it away.
Subscribe to Johnson's Math. Smash that like button.
Love you guys.
See you later. See you
Hugs and
tomorrow.
kisses to you.
Okay, do the quiz. Bye.